Good day everyone, welcome to Easy Pass tutorial. In our previous class, assignment was given. Today we are here to find solution to the assignment. Assignment was taken from 2022 Waec question under volumetric analysis. According to the assignment, it says A is a solution of potassium permanganate 7 containing 0.02 mole DMQ. B is a solution of iron 2 obtained by dissolving 3.8 grams of iron granule in 250 centimeter cube of solution. Put A into the burette, pipette 20 or 25 of B into a conical flask and add 10 centimeter cube of A2SO4. Titrate it with A. Question that was asked is that tabulate your reading and calculate the average volume of the acid used. We have equation on the board taking the mass of potassium permanganate to be 158 grams and iron to be 56 grams. From the result and information, we were asked for the B part to calculate the molar concentration of B, the concentration of B in mole DNQ, then the concentration of B in gram DNQ, the mass of iron 2 that will dissolve into 50 centimeter cube, and the percentage of B. These are the questions that was given to us. When you look at this question very well, you find out that this question is under redox titration. Then in this question, KMnO4, which is potassium permanganate, is acting as the acid, while the iron is acting as the base. Under that question, you are asked to add 10 centimeter cube of A2SO4 and titrate it with what acid. The function of that A2SO4 is to provide the acidic medium during that titration, and also to power the oxidant during titration. Is to provide one, it provide the acidic medium during titration, and secondly, it gives power to the oxidant during titration. Then tabulate your reason and calculate the average volume of the acid used. Solution to that question. A table was given to you. You form a table to be burette reading. You have burette reading. 2, you have final reading. Final burette reading. 3, you have initial burette reading. Here you have your rough. The function of the rough is to clean up, is used to clean up the equipment, or used to clean up the apparatus. You have the rough. There you have first reading. Here you have second reading. You have second reading. On that rough, we assume to be 80.50. In your first reading, you assume the rate to be 80.10. Rough must be higher than what? The first reading and second reading. Because we assume that there are some particles inside burette of which the rough might clean up. There are some particles inside burette or pipette, which is the apparatus the apparatus used to carry out this particle. You find out that when you titrate the first time, rough supposed to be higher than what? The first reading and the initial reading. In order for you to have what? A clear reading, you must what? Carry out what? Rough to clean up the apparatus. We have first reading, we assume to be what? 80.10. Second reading, we assume to be what? 18.20. Or the difference is supposed to be what? 1. Initial reading, we have 0.00 because the burette is up to the top of the bullet is measured at what? 00, which is stand for what? Initial reading. We have 0.00, 0.00. Under this table, we assume that you carry out the practical 2 times. You have to divide by 2. When you carry out the practical 3 times, you divide by 3. So to calculate the average volume of A used, which is what? Volume of A used. Volume of A used. Your A is what? KMnO4, bracket open, KMnO4 is equals to 80.10 plus 80.20 divided by 2. Then you have 36.130 divided by 2. Divided by 2, we have 80.10. Look at the question on the board. The question was given to you on the board. It said from your results and information provided, calculate the correction of B in mode DNQ. Before we calculate correction of B in mode DNQ, please don't forget to put the unit for the volume of what A used. The unit is in centimeter cube. You can leave your answer to be 80.10. You can leave your answer to be what? 80.5. Your answer can also be what? 80.2. Approximate 80.15 to give you what? 80.2. Look for your results and the information provided. Calculate the correction of B in mode DNQ. Look at the question given to you on the board. The formula is CA VA all over CB VB equals to NA all over what? NB. Where you see A is the concentration of acid, concentration of A in mode DNQ. Your VA is the volume of acid, which is volume of A in centimeter cube. Your CB is the concentration of what? Base, which is your what? Ion, which is the ion 2 in mode DNQ. Your VB is the volume of what? Base in centimeter cube. Your Na is the number of acid, while your Nb is the number of base. Your potassium permanganate represents your A, which is what? Acid. We have one molecule of potassium permanganate there. Your number of acid there is 1. Why that of number of base is 5? Because we have 5 molecules of what? Ion 2 granule. So your number of B is 5. Concentration is always measured in mode DNQ. Your concentration of acid there is what? 0.020 mole DNQ. While your volume of acid is the one you got from your table, which was 80.10 centimeter cube, because that's what we are using for now. Then your VA is given to you. Your VA is either use 20 or 25 centimeter cube, which stands for pipette. But in this calculation, we are to use 25 centimeter cube. Then your CB is what we are looking for. Please, your CB is what we are looking for. Your VB is which stands for pipette. We are using 25 or 20 centimeter cube. So we have CA to be 0.020, VA, which is the volume of acid, to be 80.10 centimeter cube. This one is mole DNQ. Your Na, with number of acid to be 1. Your CB, that's what we're looking for, to be unknown. Your VB to be 25 centimeter cube. Your NB to be 5. You have CA VA all over CB VB equals to NA all over NB. The first thing you have to cross multiply. You cross multiply. When you cross multiply, you have something like this: CA VA times NB equals to CB VB times NA. We have CA VA NB equals to CB VB NA. We are looking for what? We are looking for CB. Divide both sides by VA NA. We have divide both sides by VB NA. VB NA. Here we have VB NA. This one will cancel this. This one will cancel this. We have CB is equals to CA VA NB all over VB NA. Where your CA is 0.020 times your VA is 80.10 times your NA is 5 all over your VB is 25, your NA is 1. When you plus everything together, we have 1.83 divided by 25. It will give 0.07, approximately to what? 0.1 mole dm³. So our BII, so let's apply our value. Our CA here is 0.020 times VA, which is 80.10 times NB, which is 5, all over our VB is 25 times our NA 1. Here we multiply the upper side, you have 1, we have CB is equals to 1.81 divided by 25. Then your answer have what? 0.07, approximately to be 0.1 mole dm³, which is our concentration of what? B in mole dm³. So another question was to calculate the concentration of B in gram dm³. So for the BII, we have concentration of B in gram dm³. Recall, the answer gotten from volume of acid is 80.10 centimeter cube. You can have 80.15, you can have 80.2 centimeter cube. Also, the answer gotten from correction of B in mole dm³ was 0.001, approximately to be 0.1 mole dm³. Now, for the BII, they were asked to calculate the concentration of B in gram dm³. Concentration of B in gram dm³. Recall, the gram given to you there, you have the formula is, we have the concentration of B in gram dm³. Recall, the gram given to us to solve was 3.8 grams of iron into 50 centimeter cube. When calculating gram into 50 centimeter cube, you have to apply the standard volume, the standard volumetric flask, which is 1000. If you are given question in gram, you multiply by 1000. But if you are given the question in mole, you divide by 1000. You have something like this. You say concentration of B in gram dm³. We have 3.8 grams times 1000 divided by 250, because the question was given to you in gram, which is what? Gram times volume all over 250. When you have gram times volume over 250, you have the formula, your answer to be 50.2 gram dm³, which is our B part. 50.2 gram dm³. And recall, if you are given a question like this, gram into 50 centimeter cube or gram 500 centimeter cube, if you are calculating gram, you have to multiply by 1000. Multiply by 1000 all over the centimeter cube given to you. Here the question given to us was 250 centimeter cube. That's why you want 3.8 times 1000 divided by 250 to get your what? Your total gram. The total gram of what? Iron is 50.2 grams.